Right, recording again, part 2 of PONG. So we've got to like a reasonable state. We've got a time-based movable objects, one under player control, the paddle, one under its own control, the ball, and we've got simple collision detection and response. That's actually not bad. In fact, things are just about complicated enough now that you might want some diagnostics to help you debug stuff. And it turns out, I always find this very important if I'm writing something. As soon as it gets beyond a trivial state, I often want to add things that will help me debug and trace the behavior of the thing, because it starts to get very fiddly. And one of the useful things for doing that in a game is just the simplest thing of being able to pause it and then single step it as well. It turns out whenever you're in development on something, by its nature, it's always got something wrong with it, right? Because if it didn't have something wrong with it, it would be finished and you wouldn't be working on it. Development is a constant process of pain. It's a constant process of things not working or not being done yet, and having visibility into how a system is behaving so that you can figure out what's happening or not happening, as the case may be, turns out to be very valuable, and it's worth doing it. And I think people forget this because it's not obvious. Like the end product won't have obvious debug facilities in it, although actually they might still be there behind the scenes. But people tend to forget that real games are full of this stuff. Real games are full of special stuff that the developers can type in. You've probably seen obvious ones like the console on an FPS game, where you can sometimes type things in to do special commands. But real games are often full of diagnostic timing systems and special keys that let you warp the camera around from place to place and do things that are not part of the game. They're not part of anybody's feature list as such, but they turn out to be very useful for development processes. It turns out that pausing and single stepping is one of the simplest things that you can add to give you some visibility into your system. So, for example, if I have I'm trying to debug a collision behavior, if you just try to do that by purely looking at the code and just looking at very complex conditions and weird numbers that you don't know what they are, it's quite hard to do it. But if you can just go into the game and actually reproduce that situation and then pause at the point of collision and then start tracing through it or look at it frame by frame so you can see what's going on, can make things easier. And it turns out it's quite easy to do that if you use the kind of main loop that I've suggested. If you have that separation of inputs, update and rendering, there are a couple of simple tricks you can do that make it quite easy to add these things. All right, so this logic for pausing is kind of about the core update behavior. So it's actually straight into update simulation is where we're going to go. Because if you think about what a pause is basically you're kind of running things as normal, except you don't actually update things. But you still do everything else. You still gather inputs because you still have to keep track of key presses. In particular, you need to keep track of the person leaving pause mode, because if you don't track that, a pause will be an infinite loop. And you want to keep drawing things because sometimes it's useful to keep rendering stuff even though you're not actually updating the internal logic sometimes. So the way I do it is I just take the update simulation code that previously just said update ball, update paddle, and I put this very simple bit of logic on it that says if we're skipping the update, which is what pause mode basically implies, then you just return early, so you just don't do anything. And now the question is, how do I decide whether to skip an update? Well, the simplest version is, down here, should skip update, where I just say, I'm going to have a pause key, so I'm going to use P for pause, just use the usual thing to set key pause. And if that key happens to be down, then I'm going to skip the update. And that just means that if I go over here and I hold down P, nothing happens anymore. Right? The ball just freezes, and that's because I'm holding P down. And then when I let P go, it moves again, and if I hold it down again, it's on. So in theory, I could now use this to kind of go and look at a collision in a bit more detail. I could just see, you can see that it overlaps quite noticeably, but weirdly your eye doesn't object so much, and it actually sort of looks okay, even though it's definitely cut in the corner. The downside here is, though, in order to see that, I had to get it exactly right, which I'm actually quite good at today, but it's kind of a little bit annoying that you have to be kind of frame accurate to do it. If you wanted to just catch that, it's like, I'm going to keep doing this, it's a little bit tricky. So it would be nice if we could do instead of it being a pause is just a thing that you hold down, one thing would be nice if it was a toggle, where you could just say, go into pause mode, and I didn't have to keep holding it down, and I could toggle in and out of it, and it's maybe slightly preferable that way. So if I wanted to add a toggle-based approach, I would do this separate piece of logic I've got down here. So what you do now is, instead of just basing it just on whether a certain key is pressed, you base it on whether the game is in the paused state. And that's a bit like, having the trail on or off. It's just a boolean that you track. So I create like a boolean called G is the update paused, and then I toggle it by negating it. We do something equals not the thing. That's you flipping it. So the naive version of this is that I could say if G key is key pause, toggle the update. But I have to do something a bit fancier than that, because if I just made this based on reading the key, in fact I can show you what it would look like. So let me do a couple of things here. One is I'll change this to be kind of not the right thing. If I can, Alt, isn't it? Key pause. Like that. And put the curly thingy in. Boom, boom, boom. And comment this bit out to make it go away. Right. So this is me changing it to use this naive thing about is the pause key down as my toggle. The other thing I need to do is make it run this piece of code. Nice little thing you can do in JavaScript, because functions are just variables that you can throw around. I can do this thing here where I've currently said that my skip update routine is using the version 1 implementation. I can just say I'd rather use version 2 instead, please. And now it will switch to use this one down here. And if I run that, in your own time, has that? Yeah, it did reset, okay. So now if I press P, it's paused, okay? And I've taken my hand off the key, and if I press P again, it should go and stop, and except it isn't always working, right? Sometimes it's going into pause mode, and sometimes it isn't working. Can you figure out what's going on here? So it's like I've tried to implement a toggle where when I press P, it should switch between is paused and is not paused. So what I'm actually getting is it sometimes works and it sometimes doesn't.
It only works when the game rates your key press as an even.
Correct.
Presses because
yes.
We're pressing it out.
Exactly. It's brilliant that you spotted that. So the problem here is, because we now have a time-based loop that's running 60 times a second and is just looking at the state of things and it's not reacting directly to events, it's reacting to the state. So the problem is that now if I press the P key for an even number of frames, it'll toggle itself on and back off again, and it won't make any difference. So unfortunately, when you start using a time-based system, if you're going to have a toggle, it's kind of not going to work, or at least it'll only work half the time, right? It'll only work if you hold it down for an odd number of frames.
It was also possible to get a similar problem in the last homework. Mm-hmm. If you were using the mouse, if you were moving the mouse around a lot, causing frequent updates, and you could get the same problem with the back, like other toggles.
Right. Okay. Fair enough. So that was just, I won't repeat the whole thing, but the claim was that the previous homework could suffer from that as well, based on the mouse events, which I don't think I've actually seen, but I believe that it could have happened. So the problem with the naive approach here is that toggles become hypersensitive to how many frames you hold the key down for, which is just not a reasonable expectation. So that's why I had to add this thing called eat key. So what eat key does is, it doesn't just look at the contents of the key array to see whether the key's down. It looks, and if the key's down, it kind of it resets it. It sets it back to false, so that you only process the key press once, even if it's held down, right? So if I go and change this piece of logic to saying eat key, and eat key is just a routine that I added to the key handler way up at the top, wherever I put it. Here we have it, eat key, right? So what eat key does is it checks the state of the key to work out whether it's down or not. So it reads the key, and then whether the key is down or not, it sets it back to false. So this changes it from being a thing where the array lets you know, is this key down or up right now, it changed it to more like a system where when you press the key, you kind of raise a flag that says, okay, I'm down. And then as soon as you read it, you put the flag down to say, okay, I've read you. And that way you only read the key. You know, the fact that the key's being pressed only gets read once instead of being read like multiple times for every frame. So I hope you understand that's maybe a little bit non-obvious, but it's something you need to do for toggle keys, otherwise they'll behave really erratically. So having put that bit of logic in now, where we eat the key, this should actually behave a bit better. And when I run it, I should hopefully find that when I press P, it pauses, and I've taken my hand off it, and I press P again, it should unpause, pause, unpause, pause, unpause, pause. So that's working kind of ideally now. Almost. There's actually a little subtlety here that if I hold the P key down now, does anyone have an idea as to what would happen if I, instead, because I've been toggling, so I'm just pressing kind of fairly quickly, but what if I press the P key and I hold it down? Yeah. Well, what will happen is the same as everything else. It'll work to begin with, and then the auto repeat will kick in, and that'll create new key events. And every one of those new key events, when it gets processed, will be interpreted as a toggle, but only once. And then the new key event will come in and it'll toggle again. So what happens is if you hold down P, you get slow motion, because basically what happens is it's going in and out of pause while I'm holding it down. So in a way, it's almost convenient. It's like a very crude slow motion mode if you hold P down, and then if you let it go, it'll either pause or it'll move depending on the odds, and thereafter you can toggle it. All right, but again, we still have the problem that if I wanted to identify like a precise moment, like I wanted to debug the exact collision thing, I'm still at the mercy of being, kind of having to judge exactly the right moment. What I really want now is single step. What you do with single step is you pause it, and then I want to press a key that says go forward one frame, and just one frame at a time. And the way you do that is you just create a thing called, in my case, key step, which basically it works alongside the pause. Basically, what it does is it takes the brakes off the pause for one frame. Right? So this extra bit of logic down here, that just effectively means that if the thing is paused, then this would return, skip update, unless the step key is pressed, in which case that causes if step key is pressed, that's true, therefore the not is false, and if you AND something with false, you end up with false, right? So this is basically a way of, as I say, disabling pause for kind of one frame. So it turns out I can go over here, and I'm in pause mode, but if I press O, it'll do one frame forward. Just exactly one frame. And that's really nice, because now I can get close to the thing that I'm interested in, which is this collision thing, and I can just go exactly into it, and you can see that's where the ideal collision should have occurred, but actually I go forward, and I go forward again, and then eventually I detect that I'm hitting the midline, and that's when the bounce occurs, and now I can see all that quite clearly, and I can also check for these little corner cases, pause, single step, and I can see exactly what happens as it cuts the corner, and eventually sort of hits, even though maybe it shouldn't have done, and this is how you can kind of trace through the behaviour. Just a simple convenience, but worth mentioning. And also it tells you a little bit more about how toggles work and how you deal with mucking around with time. So that was pausing. Oh yes, there's something else we need to add to our PONG game that's been missing, and that's the second paddle. So the kind of obvious way to do that is if I just took the code for the first paddle and copied and pasted it and, give it a slightly different name. I'd have to change the first one to gpaddle1 and the other one to gpaddle2. And, I mean, that would work, right? But it would be hideous. We don't do that, right? You all know that copy and pasting code is sort of bad, yes? Yes? Yeah, it depends. So the reason that copy and pasting is sort of bad is that, first of all, it makes your code unnecessarily verbose. It also means that if ever you change anything, you have to change it and find all the copies and change those as well. And it's easy for that to go wrong. If you've copied and pasted something 5 times and you said you want to change it, and you only remember to change it in 3 places, so the other 2 places are still doing it the old way, and now you've got bugs. And it's just a totally stupid thing to do, right? If you see yourself copying and pasting, it's usually a sign that you should have pulled that thing into a function, and you should be calling the function from 2 places. Not always, but that's often the rule. And that's what we're going to do here. We're not going to copy and paste the paddle. We're going to generalize the things about the paddle that we care about and separate the general things about paddles from the specific things about the two paddles we've actually got. Now, the way you would do that in an ordinary object-oriented language is you would say, what you would do is you'd identify the paddle class, and that would contain the general code that's true for all paddles, and then you'd create two paddle instances, which are, they run the same code, but one of them's in a different position from the other one. But it turns out that JavaScript, although it now has classes, didn't originally. Originally, it was based on this idea of prototypes that I've mentioned, which is just actually very similar. It just means that instead of an object having a class, it's got a prototype object that it shares behavior with. And it turns out if you do use classes in modern JavaScript, really it just creates prototype objects behind the scenes. So I'm going to show you it the prototype way, which in some ways you can actually argue the prototype thing is arguably more flexible sometimes. Right, so let's go down to the paddle. So this is the way it used to be. We used to have a global paddle with all this code in it. But in order to generalize to what it's doing with the two paddles, we want to pull out the general parts of a paddle into a paddle prototype, and then we'll just create two instances of that prototype. So here's how I do it. gpaddle1 is created here, and it's very similar to the way it was. I've got X and a Y and up and a down. But instead of just creating a bare object, like I did up here, where you just created the object, curly brackets, object, you're done, I do this little trick here where I actually call a constructor called paddle, and I pass the parameters into the constructor. So what's going to happen here is I'm making this object, but I'm telling it that I want your prototype to be the paddle prototype. That's approximately what I'm doing. So it's a lot like creating an instance of a paddle class. Logically, roughly equivalent. And for paddle 2, you can see that I do basically the same thing. I create a paddle, but the parameters are a little bit different. Like the X position is different because I want this paddle to be on the right of the screen. And the keys for controlling it are different. Previously, I had the old paddle would just have this thing where we kind of hard-coded key W and key S into the update logic. But we can't do that now because the two paddles have got different, obviously wanting to be based on different keys. So we need to abstract that out. So what we do is we call them by the abstract names, which just go up and go down. And for paddle 1, that's W and S. And for paddle 2, we're going to use I and K. So I just define what I and K are in terms of their key codes. And I say when I'm constructing paddle 2, I tell it that I want your up key to be I and your down key to be K. So that's really nice, right? We haven't had to do a huge amount of copying. We've just said, look, almost the minimum that we need to say, which is to say this paddle's got a different position and different keys. And it's like, okay, I have to say that, right? But I didn't have to do a lot of ugliness. So what's actually happened here is that all the code that used to be inside the paddle, what used to be the gpaddle update and the gpaddle render, they now go into the prototype object instead. So this part here is where I take the common paddle parts. Now, prototypes are a little bit strange, and I'm not going to tell you all the details, but basically what's happening is you have this constructor function called paddle that simply takes in this thing I call a descriptor, which is just this block of data in here. Right? This is just a bunch of named parameters. This loop just goes through those parameters and it just drops them into the instance. Right? This is me just copying the member variables into place. And this is just like standard. You don't really have to think too much about it. And then we have the actual code. So the code goes onto the paddle prototype object when you're doing it in this style, when you're using the prototype style. So what I've got here is, where previously we had gpaddle.update, we've now got paddle prototype update. And it's just the same as it was, except it now says go up and go down. It uses the abstract names. And the renderer, again, is just almost exactly the same as it was before, but now it's a method of the paddle prototype object. So that's it, we've now got two paddles. The only other thing we need to do to make this work is when we go to the core of the main loop, we need to make sure that our update routine updates both paddles. So we just have to type that in, extra line, and we have to make sure that the renderer renders both paddles. slightly ugly that we're having to say that, but it's not too offensive. So now we've got, that's it, this should work, we've got 2 paddles. We're not seeing it, of course, but that's because I've done my usual trick of commenting this thing out so it wouldn't show prematurely. But if I run this now, hopefully we'll get it. Anytime now. Yay! So we've got 2 paddles and they're both controllable. And you can see that the ball bounces nicely off this first one. But guess what? Does anyone see it coming? It goes through the second one. So why? Why isn't it? Why? I mean, we did everything right. We created 2 instances. Why isn't it working?
Something is tied to the ball paddle.
Anybody else? Got that?
Still, we only check if it's going from the right side to the left side.
So there were a couple of points there. Yes, we're only checking for a right side to a left crossing, and also it's only the ball that's doing the collision detection, and that ball code didn't change. That ball code is still hard coded to just deal with the first paddle. Now, actually, it changed a little bit because it used to say the ball code used to check against down here when I was doing all this stuff. This used to be G paddle. I changed it to G paddle 1 so that it wouldn't just completely fail, because that's what we've renamed the paddle to. But the problem is all this logic here is tied to a particular paddle. And in a way, this is sort of an indicator of global variables are bad, right? Among other things, the problem with global variables is you've only kind of got one instance of them. And if you take something and you try and generalize it and create more of them, all your references to the one global variable are now kind of screwed up. So the problem here is that the ball is hard-coded to only do the checks against the first paddle, which is rather annoying. So what could we do to fix this? Well, the dumb thing to do would be we could copy and paste this code here and have it do all the same logic against paddle 2 as well, right? But again, I've just told you, you don't want to do that. What if we added a paddle 3? Not that you're likely to, but it's a principle of the thing. So we don't want to do copy and paste to make it check against both paddles. So what do we do? I mean, what did we do to stop copy and pasting all the other code about the paddle?
Check against the paddle prototype.
Right, check against the paddle prototype. So that's basically the impulse here is that instead of having to duplicate this kind of slightly clunky piece of code already, what we want to do is you can't directly check against the prototype because you do care about the instances. You care about paddle 1 and paddle 2. But what I want to do here is instead of having to copy and paste the code, I want this code to go away and be a function inside the paddle. And I can just say, check against paddle 1. Do collision check paddle 1, collision check paddle 2. And that way it's just 2 simple lines. It's perfectly obvious what we're doing. And we just have this code here that is actually kind of, you can see now it's in a way it's in the wrong place because this is code that's inside the ball update, but it's full of logic about the internal details of the paddle, which are not really the ball's business. There's always a bit of a debate here. You can never resolve this perfectly, but what I want to do is move this logic into the paddle and have the ball say to the paddle, am I colliding with you? And then once you've done that, you can say, am I colliding with paddle 1? Am I colliding with paddle 2? And the ball will decide, if it has collided, the ball will decide whether to do the bounce because that's the ball's business, because the ball will have to update its own velocity. But the checking for the overlap, we're going to say, I want you to ask the paddle about that. Ask the paddle whether you're hitting it. So that turns out to be how you make the next step here. Okay. Right, so we've done a bit more revision to the code here, which includes, so the paddle prototype we just created the last time, it had an update and a render, that's fine. We've now pulled out the part of the collision detection that's looking at the inside of the paddle, and we've said we're going to make that a method of the paddle prototype. So now we've got paddle prototype collides with, and this is basically a slightly modified copy of the code that we previously had inside the ball, right? But it now belongs to the paddle. And what you do is the parameters you take in are the next and previous positions of the ball. So that's the ball saying, I was here, and if you don't do anything to stop me, I'm going to be here. So you let it know both those positions, and now the paddle can check for whether a collision has occurred. Now, as someone pointed out, the original collision code only detected crossing from right to left, and to work for the other paddle, and in fact to work symmetrically for both paddles, you need to detect both types of crossing. That's what this second line here does. This just generalises the first line above is what we had before that detected like a right to left crossing. This is a very similar one where you just flip some signs, and that'll do the left to right crossing, which we definitely want for the paddle that's out on the right hand side. So I add this line to make it handle the symmetry. The rest of it is just the same as it was before, and we've just wrapped it up into a function inside here. And that means when I go down to the ball, instead of the ball having all this paddle logic in it that shouldn't really have been there, we just have this, I just have to extend this so you can see it in one line. We just have this instead. We have checking against paddle 1, and you say if you collide with paddle 1 or you collide with paddle 2, in either case, flip your X component. So what we've done here is we've generalized it quite nicely without making the code much uglier. In fact, we made the code nicer. This is simpler looking than it was before, and we've moved the logic into a better place. It kind of is a nice little self-contained function. So we're winning here. This is actually an improvement, and it has additional behavior. Way! Okay. Just pull this out a little bit so you can see it. So we've now got two paddles, both of which have got reasonable collision logic on them. So I can actually almost play a game of Pong against myself. We still have a thing about it can go off screen because we just haven't done anything about that yet. But that's actually in a reasonably good state now, I would say. Not perfect, there are definitely things you could do. What sort of things, what else do we need to do here? What haven't we done yet? So, okay, so somebody said sound, and that's true, and I'm not going to do sound today. I'll describe sound briefly a couple of weeks down the line, but yes, sound is missing. Scoreboard is missing. Okay, randomising the ball direction. Those are all good suggestions of things that you could do to make this a little bit nicer. You could maybe even spruce up the graphics a little bit. I know the Pong tends to look quite plain because it originally was in the 70s, but we could add some colour or something to the paddles and things, couldn't we? No reason why not. In fact, this little ball here looks rather plain. If only we had some slightly nicer looking round object that we could maybe use as our ball, that could maybe rotate or something. That would maybe be cool, I don't know. Just throwing it out there as a suggestion. Which leads me to your homework. So your homework this week is to finish off some of these things that we haven't done properly yet. One thing I want to suggest is, it just turns out for convenience, although traditionally the ball in Pong, when it goes off screen, it does indeed go off screen and get reset. If you actually make it bounce when it hits the left and right edges, that can look quite nice. It'll just, it'll rebound back into play, and you can still keep going, and it gives you something to do, right? It's just my way of letting you write a little bit of your own bounce logic. So make the ball bounce off the left and right edges instead of resetting. Add a score. Stop the paddles from being able to go off the top and bottom of the playfield like that, which is a bit ugly. Make them stop when they reach the buffers. And also, this is something you don't often see in Pong, but the very original one, the Ralph Bayer Pong, way back from the first lecture, in his one, I don't know if you remember, the paddles could move left and right as well. Not completely, because if you let move completely, you'd break the game. You could totally move to the other guy's goal, right? But they can move a little bit within a boundary. A bit like a striker can kind of move back and forth, I guess. So you can do a little bit of left and right motion on the paddle within some constraints. And while we're at it, why not add a second ball? Because I'll show you how to add a second paddle without doing a lot of copy and paste. Maybe add a second ball without a lot of copy and paste. See if you've kind of learned the lesson. So that's what I want you to do for your homework. And in order to show you what that should look like, I'll actually give you a demo of it. But because some people will probably want to look at the demo in isolation, I'll do that as a separate recording. So I'm just going to do a quick stop and start. Okay.